Hello, welcome back to Mrs. Torres' YouTube channel. We are going to do one more example of finding all of the solutions to a given equation. So we're going to start how we always do. Step one, we're going to find our possible rational solution. So we've got to find our P's and our Q's and our possible rational solutions. So P, we're going to look at our constant. So that's plus or minus 1, plus or minus 7. For our Q's, we're going to look at our leading coefficient. That's 3. So the factors are plus or minus 1, plus or minus 3. And then to find our possible rational solutions, we have to divide them. So 1 divided by 1 gives me 1. 1 divided by 3, just leave it as 1/3. 7 divided by 1 is 7. 7 divided by 3, we'll just leave it as 7/3. Now that we have our list of possible rational solutions, we're going to find our rational solutions by using our calculator. You can't really see this calculator, let me grab another one. We need to put our equation into our y equals. So y equals, clear out whatever's in there. We have 3x to the 4th plus 4x squared minus 7. So we put this equation here. Then we go to the table. So that's second graph. And our table should already be set up so we can plug in our values and see which one is our solution. So we've got 1, negative 1, 1/3, negative 1/3, 7, and negative 7. Then we look at the y's. We're looking for 0. So it looks like x equals 1 is a solution, and x equals negative 1 is a solution. We still have 7/3 to check, so let's check that really quick. 7/3, nope. How about negative 7/3? No. So our two rational solutions are 1 and negative 1. So we know these are two rational solutions. So then we want to ask ourselves, well, that means how many either irrational or imaginary solutions do we have? We know we have 4. Here's 2, so we're looking for 2 more. Now remember, because these are rational solutions, if we were able to factor our original equation, it would factor into x minus 1, x plus 1, and then it would leave us with another polynomial. Because the solution to x minus 1 equals 0 is 1. The solution to x plus 1 equals 0 is negative 1. So we need to figure out what that other factor is, so we can set it equal to 0 and then either factor or use quadratic formula. So what I'm going to do is I'm going to take my first rational solution, so that's 1, and I'm going to use it to synthetically divide. So really, I'm dividing 3x to the 4th plus 4x squared minus 7 by x minus 1 to see what we get, because we're dividing out that factor. Now in this case, we have 2 factors that we know, right? So whatever we would get here, in order to get this polynomial, we have to then divide out x plus 1. So we're actually going to have to synthetically divide twice here. So first, I'm going to start with x minus 1. So if we take the opposite, right? If x minus 1 equals 0, that means x is 1. So we put that up there. And then we take the coefficients of our polynomial. So we have 3. We don't have an x cubed term, so we need that placeholder of 0. We do have an x squared, so that's 4. We don't have an x term, so that's 0. And then our constant is -7. Remember to put your box there. Whatever is in here is going to be our remainder. So let's go ahead and synthetically divide. Bring down the 3. 3 times 1 is 3. And then we add down. So 0 plus 3 is 3. 3 times 1 is 3. Add down again. 4 plus 3 is 7. Multiply again. 7. 7 times 1 is 7. We get remainder 0. It's very important that we get remainder 0 because we know x minus 1 is a factor of our original polynomial. So this should always be 0. If you get a remainder, you did something wrong. Go back and check. Now, normally we would write our answer. But like I said, we have to divide by x plus 1 as well because we have 2 factors to divide out. So what I'm going to do is I'm just going to start that synthetic division right here. So now we put our bar. And now our remainder is under our constant, which is 7 this time. And we're just going to do the same thing that we did. So we're just synthetically dividing twice. So bring the 3 down. 3 times -1 is -3. Add down. You get 0. 0 times -1 is 0. Add down. You get 7. 7 times -1 is -7, which gives us remainder 0. Again, we have to have remainder 0 because they're factors. They're always going to divide evenly. If it does not divide evenly, either these are not your correct factors or you divided wrong. Now let's write our answer. So remember, this is our constant, x term, x squared term. So we have 3x squared plus 7. Now, let's think about what 3x squared plus 7 really is. That is our third factor. We can't actually factor this one. We had to use synthetic division and kind of do the roundabout way. But our original polynomial can be rewritten. X minus 1, x plus 1, 3x squared plus 7 equals 0. We found these using our P's and Q's in our calculator, and we found this by doing synthetic division. Now we have an equation that we can solve. So I'm actually going to bring this down here. Give myself a little more room. So now that we are multiplying 3 things together, and we know how to solve this, we know how to solve this, and we know how to solve this, it's a quadratic. We can use zero product property. So x minus 1 equals 0, x plus 1 equals 0, 3x squared plus 7 equals 0. So our solutions are x equals 1, x equals -1, which we already knew. We found those, but I'm just showing why they're solutions. And now we have a quadratic. So we know a bunch of different ways we can solve a quadratic. Since we don't have an x term here, I'm just going to solve it using square roots. So subtract 7 from both sides. 3x squared equals -7. I'm going to divide by 3. Get x squared equals -7 over 3. We've got to take the square root of both sides. So x equals I times root 7 over root 3. We can't leave that root 3 in the denominator, so we've got to rationalize. So we'll get I root 21 over 3. And don't forget, I should have added it over here actually. When you take the square root, you get the positive and the negative. So those are our 4 solutions, because we have 4. X equals 1, x equals -1, and x equals plus or minus I root 21 over 3. Remember, since this is positive and negative, those are both your solutions. All right, that's it for today.